So for question 20, so we are going to express this fraction in partial fraction. So before we express it out in partial fraction, first we have to make sure the fraction we get here is proper fraction. So where this power of numerator is power of 2, denominator when we expand it, it will be power of 3. So quadratic over cubic, it will be a proper fraction, then only we continue to express it in partial fraction. So when you want to express it in partial fraction, we are going to separate it by its factors. So our factor here is x minus 3, another factor here is x squared plus 2. When we get a quadratic factor, we have to very be careful here. We have to make sure our quadratic factors here is factorized completely. Like for this case, x squared plus 2, it is original, cannot factorize anymore. That's why it will be maintained it as quadratic factor. Or not, if for the quadratic factor that can still be factorized in linear, then we will going to factorize it completely and use its linear factor. So after we make sure our denominator factors here are correct, then only we determine what's the constant up here. Once here is linear, means our numerator will be a smaller ranking, will be a constant a. So once our quadratic is at denominator, so the smaller ranking here will be a linear. So the linear will be in the form of bx plus c. So this is how we express our fraction into a partial fractions. The next step, we are going to find out what is our a, b, c. So we have to going to equal the numerator where 3x squared minus 5 for the numerator part. We compare the numerator part. So for this numerator a, they need to time with the factors that it don't have, which is x squared plus 2. Meanwhile, for this px plus c, we have to time with the factor that it don't have here is x minus 3. Then we going to find out what is our 3 unknown here. So when we have 3 unknown here, means we have to build up 3 equations. We have to put 3 information here. So we can do the method of let, or we can expand and we compare. We have 2 methods here. One is letting, one is comparison. So from here, I will choose the method of let. So I will let the roots of the factors here. So the roots here will be, if you look at our factors here, our roots here will be 3. So when I let x equals to 3, it will be more easier for us to find out the unknown. Substitute the 3 into the whole equation here. So here will be 3 squared, 9, 9 plus 2, 11a. And then when we substitute 3 into the factors here, it will be zeros. So we can get the value easily. So this is how we get our first unknown a. And then we will continue to let others value. So the values we can let when we have a linear factors of the unknown constant here, another choice our x will be 0. So when putting our 0 here, it will equal to negative 5. So of course our a we already found, we will use it. And then here will become c times negative 3. So we will have negative 5 minus 4 become negative 9 equals to negative 3c. So c is 3. So the last value here, x, we can put any values. So for us easier to calculate, I will put value 1. So when I substitute here, I get negative 2. So a is 2. Then 1 square plus 2 is 3. then 1b plus c. So b plus 3. Then 1 minus 3, negative 2. So substitute it one by one here. Substitute 1 here, substitute 1 here, and substitute 1 here. And then what we can get? We can get this one, 6, move there, will become negative 8. And we divide by our negative 2, means our b plus 3 here will equals to 4. B will equals to 1. So this is how we solve our 3 unknown by letting 3 times. When we letting 3 times means we have 3 equations here. So finally, we will writing back our unknown ABC so that we can express our fraction into the partial fraction completely with the numbers, where our A is 2 and then B is 1, so 1x plus C over x squared plus 2. So from here, that is very important for the first step, that we know how to write out our partial fraction forms, where you need to know how to separate it by its factor and how you determine your A constant or linear constant. So you bear in mind, always be a proper fraction. So means when this is linear, up there will be constant. If this is a quadratic, up there will be linear. So it will always be proper. Then we start our concept of equation. We build out our equation here, multiply with the factors that we don't have, and then we start letting it 3 times because we have 3 unknowns. So this is our concept, letting it 3 times and get to the answer. Get to the answer, the first answer and the second answer refer to here, B and C. So finally, we have to write it back into the fraction form. So this is how we solve our partial fraction.